No.
Britt, talk. So, what's the deal with our mRNA again? How long does it stay in your system?
4 hours.
And then you said it doesn't move. Like, say what you just said.
It doesn't move, so it goes into your arm, and it's in your arm for 4 hours. And essentially, it teaches your body how to respond, and then it quickly degrades. It's not stable, so it's 4 hours, and then it's out of your system.
And it doesn't affect your reproductive
It does
system.
not affect your reproductive
How do you know?
Because there's no way it can get to your reproductive system. It stays local in your arm.
It could possibly affect your reproductive system is if your body decides to destroy your reproductive system for no reason.
It would have to reverse the central dogma of biology.
Yeah, it doesn't affect. Well, it has not been shown to affect the reproductive system, right?
There is no scientific way it can
And there's no reason to believe that it would because other viruses don't, right? So the mRNA, to clarify, it just codes for that original spike protein so that your cells make it instead of them making it in a giant vat. It's just a lot easier, a lot cheaper, a lot more effective, right?
A lot faster.
A lot fewer ingredients.
COVID itself can affect your reproductive system.
Because your COVID will eventually go everywhere. And also just inflammation in general is something to take into account.
So, Ray, take it from the top about how RNA actually works from the beginning.
Oh, the RNA or the COVID vaccine in general?
How the COVID vaccine uses
So
mRNA.
all vaccines in general will work like this. You'll take a piece of a virus or a bacterium that is very, very obvious for your body to recognize, specifically your immune system to recognize. Your immune system will see something that it finds to be a threat, say a virus or bacterium, and it will encode special weapons called antibodies to fight against anytime it sees that again. If it sees a virus again, if it sees a bacterium again, it'll make antibodies to go fight those things, and it'll remember them. However, you don't want to get sick. These things are very, very powerful, especially bacteria, especially viruses. So the way vaccines work is by taking the parts that are really, really obvious for the body to remember, without the actual kind of agonist, without the actual enemy being there. So you basically having an empty shell of your enemy so that you can recognize your enemy without actually being attacked by it, right? And so the way a traditional vaccine would work is by basically recreating the outside, say for a virus. Viruses are a shell with usually some sort of like little protein tools on the outside, like the spike protein's a protein tool that uses it for things. And then it has DNA inside. That DNA inside is the real infection, right? It's going to replicate in your cells and make more of itself. Then it will hijack your whole body. So a lot of times they'll take the DNA out and just have the empty shell of a virus or pieces of an empty shell of a virus. And if they give you that and introduce that to your system, your body will still recognize it as something that is potentially dangerous, and it'll make those same defenses, so immune defenses against it. So for the mRNA, traditionally the way they do this is that they'll just recreate those, say, spike proteins or the outer layers of a virus. And they make them outside, and then they put them in some sort of either shell or parts of other viruses that, they don't replicate in your body, but they go in your system and your body recognizes them as foes, right? So the mRNA takes this a step before. Instead of giving you the spike protein for your body to attack, it gives you the instructions for the spike protein. And so it's called mRNA, and mRNA is what your own cells use to build proteins. And so it gives you an mRNA that's going to make spike proteins, so now you inject it. And the body eats the mRNA really quick. But in that time, your cells will have read the mRNA and made all these spike proteins, and suddenly spike proteins everywhere. And it's again that shell of the enemy, and the immune system will be like, oh my god, there's a foe there, attack it. And now it has memorized this coronavirus despite never having been infected by it.
But those spike proteins are harmless because it doesn't carry the virus itself. It just shows the structure that is the enemy, builds a defense to it. So what is the possible harm in the vaccine?
The only harm that I can think of is the same harm as getting sick, that your body reacts to it in the first place. If your body recognizes something, it's going to have an immune response, right? And that's the same thing as being stung by a bee. The toxins in the bee are toxic too, but they'll give you an immune response. The immune response is usually not nearly as dangerous in the vaccine case as it is for an actual infection, because when you have an actual infection, that immune response is now prolonged. Your body has to fight a vaccine with a kind of stalemate for sometimes even weeks.
And the problem with the COVID is if you pick up COVID and you've never seen it before, your body actually doesn't realize that it's a foe until the spike proteins are already in all of your cells. And so by that time, it's too late to mount an immune response that's actually going to be an effective immune response. So by getting the vaccine, your body then knows what it looks like. So when you get hit with it again, your body's like, oh, I recognize this as a foe, and I'm ready to attack my foe.
So you're not locked in a stalemate anymore. You're not, your body
You have
isn't
an upper
trying to
hand.
undermine itself anymore. And that's why the vaccines are really, really important. You're always going to have an immune response, and immune responses can come with some complications,
Right.
but so do diseases, and the complication from diseases are far worse. That's why you end up with long COVID. That's why you end up with people losing their senses, people potentially being debilitated from, say, polio, for example, similar virus. It's the immune response that ends up killing a lot of people for these sorts of things. That's why it's important to train your immune system early on. That's why it's very important to get vaccines. That's why you should
Okay,
also
what
like
about-
just play in the dirt.
What about the so you're producing all of these spike proteins, and then those spike proteins themselves could be causing inflammation in your body, and like what is a hazard of just those things existing?
Just the fact that your immune system is responding to them, right? It's, I mean, it's,
So, yeah.
for
most
What
people,
about a physical blockage, or if it, not, like
No,
like there
they're
could
way
be
too
an immune
small.
response. They're way too small.
No, they're way too
What
small.
what
to
size
block
scale
your
are they on?
capillaries. So they, I guess, so it would be on 100 micron scale for a virus, right?
I mean, the
So
actual.
the spike proteins should be less than a micron big. They're smaller than your capillaries. They're not going to get stuck in you, and they're much smaller than your cells.
The actual injection is incredibly small, and it's mixed with mostly sterile water.
Yeah.
I mean, you look at the ingredient list, it's one of the vaccines that has the least ingredient list of any of the vaccines.
It's
I've
actually
ever looked
very
at.
impressive. As a
And the
chemical
technology is
engineer,
absolutely
The-
fascinating.
it's very,
It is.
very cool.
The
They
first
will make a
ingredient is sterile
viral
water.
vaccine this way.
I think it's genius, and it's how we honestly should have been doing it the whole time.
Yes.
That's
It,
what I feel.
our vaccination thing, correct me if I'm wrong, I feel like it'll change significantly in terms of how
It's a lot easier. It's cheaper.
About any
It's
viral vaccine.
way more accessible. They last longer if we perfect them and stuff.
What are we talking about? The
And they're
vaccine?
probably
MRNA,
safer.
yeah. And they're probably they're
See,
probably
oh,
safer.
Probably
that's
safer.
a conversation my sister-in-law I've had with her a lot. She's been trying to get pregnant, and I've explained the
Yeah.
essential dogma of genetic biology. And she doesn't get that, like, it won't reverse, but that was basically her biggest thing of, like, what, it was a safety thing. I was like, if anything,
They're much,
biologically,
they're much safer than,
from what we understand, this is significantly safer.
much safer than a live vaccine.
Oh,
Yes.
absolutely. Yeah.
Way
And we
safer
get
than
live
And
vaccines.
that's put me into seizures, and I would
See,
get
buddy.
it again tomorrow for whatever kid I have.
That is so awesome, isn't it?
I forgot we were still on video.